Hello, folks. Today I'm going to teach you guys about significant figures. So, what exactly are significant figures? Well, these are numbers that we obtain by doing measurements. We're not by counting the number of brothers and sisters we have, how many dogs we have. We've done a measurement. We do calculations with measurements. We have to remember that we must maintain the precision of the instrument we use to do the measurement. What do I mean by that? If I step on a scale and weigh myself, my scale is going to say 125.6 pounds. Okay, at least that's what my scale says. But I can't go and tell my friends I weigh 126.53316. You see what I'm saying? In other words, my scale only goes out to one number past a decimal. So that's what I have to report. And so when we're doing calculations based on measurements, we have to be cognizant of the limitations of the instruments we use. No instrument can measure any value with absolute certainty. There is an inherent error and limitation with all measurements due to the limitations of the instruments. So, what numbers are significant? This one's easy. All non-zero numbers are significant, always. This is an easy one. I give you this volume, 62.52 mils, 4 significant figures. 32 PSIs is the pressure, 2 significant figures. 6 microliters, okay? 6 microliters, 1 significant figure. 7.89 grams per mole for this density, 3, okay? When you get these values in your textbook or you're doing your homework or you're taking an exam, you don't know what instrument was used to report these measurements. So you have to recognize the fact that these are the limitations of the instrument that you're using. Again, non-zero numbers, that's easy. Let's talk about zeros. Zeros fall into 2 categories. First category is significant zeros. These are zeros that we count as significant figures. Zeros that are written between a non-zero numbers. In other words, we have to write this zero. It's part of the value. I can't leave this space blank, okay, and have you guess how many zeros was supposed to be between the 8 and the 1. So we write it. Zeros that are at the end of a decimal and non-zero numbers. So here's my decimal, and here's my non-zero numbers. These are significant because why? I could report this value here, and it would be the same magnitude, but it wouldn't be the same measurement. In other words, the person who did this spent a lot of money for their instrument, which allowed them to take their precision that far past a decimal, and they want you to know it. The last zero that's significant are zeros after non-zero numbers, but before a written decimal. Again, I could write the number 1010 without the decimal. It's implied, okay? But when I write the decimal, what I'm telling you is I'm certain, let's say that this is a measurement of mass, I am certain that what I measured is exactly 1010 pounds, whereas here I would say, okay, well, it's about 1010 pounds. Okay, and so again, remember, significant figures aren't just telling you the value or the magnitude, they're telling you what? The precision of the instrument. So what are zeros non-significant? Okay, zeros before a written decimal. Okay, why do we write these zeros? Well, there's actually a really good reason. First of all, it's MLA and APA format, but it's to bring your attention to the decimal. For example, if you're working and dispensing drugs and you misread this 0.2 mgs as just 2 milligrams, okay, and so you may overdose your patient. And so we write the zero to bring attention to the decimal, okay? Zeros that are after non-significant zeros, but written before an implied decimal. Again, we have to write the zero because if I'm paying you to do my yard, okay, I need to write that zero so that I know to pay you $1,010 versus 101, okay? But again, that's not a measurement, okay? If it was a measurement, we would only be certain to hear in terms of my precision, okay? Zeros after a decimal and a non-zero number. So again, we have to write these because why? Just like before, I can't just write it like this and you guess how many zeros are supposed to be here. I have to write this to show you that this one starts at the thousandth place. Typically, if you can convert a number to scientific notation, drop those leading zeros, they're not significant. So this value has 7 significant figures. These first 3 are non-significant. This captured 0 is significant. These trailing zeros are significant. Now, significant figures only applies to measurements. So when we have values that are not measured, the rules of significant figures do not apply. So they are said to have an infinite number of significant figures. For example, I can easily count 6 students in this photo. I didn't have to bust out a student meter. Okay, I just know that there's 6 students. Exactly. No more, no less. Other numbers that are considered significant, counted numbers, okay? Some of our constants are significant. Avogadro's number, pi, for example, even though it's irrational, the number of pages in a book. So I hope this helped you with your understanding of significant figures. You have a good day.